Hello children. Now today we are starting our second chapter and the chapter is magnetic effect of current. Before starting this chapter, let's recall our knowledge based on magnet. Magnet. What is a magnet? Certain element which attracts iron and its ore are known as magnet. That means the magnet shows attraction towards the magnetic material. If we draw a magnet north and south and will bring a magnetic materials, any magnetic materials near to it, it will show attraction. Now the attraction of a magnet is always maximum at the poles. This S and this N, these extreme ends are known as poles. The magnetism of a magnet is highest at the poles and they slowly get decreased at the center of magnet. It is supposed that the center of magnet, the magnetism is always least, but it is not zero. So we'll move to the next topic, that is the property of a magnet. Properties of a magnet. Properties. A magnet has two types of property. One is directive property and another is attractive property. Directive property. A freely suspended magnet always points in the north and south direction. So, if we'll hang a magnet, it will point in north to south direction. This property of a magnet has used or has helped the early navigators to navigate in ocean or in terrestrial area. They used to carry a magnet with them and thereafter they find the direction of a place by suspending it freely. Next is attractive property. A magnet attracts magnetic materials. So to check that whether the element is responding towards a magnet, they brought that element towards a magnet and satisfied that whether the given thing is magnetic or non-magnetic. Now, types of magnetic material. Next topic is types of magnetic material. According to attraction, the magnetic material are classified into three categories. First is diamagnetic material. Diamagnetic material. Second is paramagnetic material. And third is ferromagnetic material. This will go for the introduction of these things because these things are not given in our actual syllabus in secondary class. Dia, the material which show extremely small attraction, or you can say negligible attraction towards a magnetic material are known as diamagnetic material. So if you go for preparing of electrical equipment, this type of elements are rarely used because they don't show any type of attraction towards the magnet. Now second is paramagnetic material. The material which show extremely less attraction but they show attraction are termed as paramagnetic materials. Third is ferromagnetic materials are the materials which show highest attraction towards the magnet. So in general engineering or in today's machinery, these elements are used for preparation of any type of devices. So we have diamagnetic, paramagnetic and ferromagnetic material. These materials are showing their behaviors towards the magnetism. Now we'll move to the properties of magnetic poles. Properties of magnetic poles. Properties of magnetic poles. Already we have discussed there, the magnet has two types of pole. One is north pole and south pole. So there are two properties also. The similar poles shows repulsion. That means if two magnets, north and south, and another south and north, are brought close to each other, they will show repulsion. There will not be any type of attraction. So this is what the similar poles shows repulsion. And the second one is unlike pole shows attraction. That means if another pole will bring, their magnet will bring, and the magnet will name as N and S, then between the south pole and north pole we'll see there is a good attraction. So a magnet similar poles shows repulsion and unsimilar poles, unlike poles, shows attraction. Our next topic based on magnet is magnet shows magnet up to a certain level. Suppose we have a magnet here, again north and south. The magnetism is highest at the poles and it is slowly getting decreased towards the center of poles. Now if we'll break this magnet into two magnets, then again we have the north and south, and there also north and south. If further we'll break it, then we have north and south, north and south, and there also north and south, north and south. That means up to a certain region the magnet shows that the poles exist in pairs. We have not a monopoles. A magnet has two poles, that is north and south. These are the basic information we have in our junior classes. Now one more information we have from our junior class that we will use in class 10 is the following. Types of magnet. Types of magnet. Now what are the types of magnet? That is, one is permanent magnet, and second is temporary magnet or artificial magnet. But the name already is clear, permanent. The magnet whose magnetism is permanent is termed as permanent magnet. That means this type of magnet retain their magnetism in every condition. The natural magnet are the example of permanent magnet. We can prepare the artificial magnet also as a permanent magnet by our engineering process. But generally the magnet which contain or retain their magnetism up to a certain time due to certain type of mechanism are termed as artificial, temporary or electromagnet. Electromagnet means that magnet we are preparing by applying electricity over it. So temporary magnet has the range of magnetism. That means we can decide what is the polarity of that magnet according to our requirement. Further, we can change the poles of a magnet, which we can't do in case of permanent magnet. So today's class we have discussed about the knowledge what we have of magnet from our previous classes. My humble request, you go through these things, will start the magnetic effect of current in our next lecture. Till then, stay safe, stay home. Thank you.